In order to solve more problems, mathematicians use the imaginary unit I squared equals -1. This, of course, allows you to do I equal to the square root of -1. And we can solve a lot more problems because this allows us to take the square root of negative numbers. Complex numbers in general are the numbers that look like this, a plus bi, where a and b are elements of the real numbers. So they're just any two real number, and then you have I in there as well. Now, when b equals 0, you can see that this whole term goes away. And a can be any real number or the entire set of real numbers. So you can see that the real numbers are in the complex numbers. They're just a. And then b is the complex portion or the imaginary portion that gives us a complex number that's not a real number. Now, when working with complex numbers, doing arithmetic on these things, we can treat I like a variable and go from there. Okay, so now when we're working with this expression, we have a complex number here, -4 times a complex number, and then plus another complex number. All we need to do is drop these parentheses and then treat the I terms like a variable. So in this case, we're going to have 6.53 minus 7.4i. I'm going to distribute the -4. It's going to give me -12 minus 32i, then plus 31 over 2i. And now I can see I have like terms here. I have a number and a number. And then I have an I term here, and an I term here. I can combine all those like terms. So this first one, that's going to give me -5.47, and then doing minus 7.4 minus 32, then plus 31 over 2. That's going to give me -23.9i. This is in standard complex form. We have the form a plus bi. A is going to be -5.47. B is going to be -23.9. If you're going to write just a real number, for instance, like 6, this would be the same thing as 6 plus 0i. That's standard complex form. And we write it this way so that it's actually going to be easier to graph these numbers, which will make sense when we talk about graphing them. Give it a try in number 1. Now, when multiplying complex numbers, you need to keep in mind this definition. I squared equals -1. But multiplying them is just multiplying any kind of polynomial. You're going to use distribution a whole lot. So for this first one, let's distribute the the 11i into this first term. We're going to get 11 over 2i minus 55i squared. The 6i minus 4 hasn't changed yet. Now, I squared is -1, so I can actually change this to a -1. And I squared is multiplying the 55, so it's going to be -1 times -55, and those cancel. So now you can see all we have to really do is distribute, use the FOIL method, distribute the first into the second, and go from there. It's plus 55 here, so 11 halves I times 6 is going to be 66 over 2i squared minus 44 over 2i. Then, let's see, we get plus 330i, and then plus 55 times -4 is -220. We can combine, or this is I squared, so we can make this -1. -1 times this, well, this is just 33, so -1 times 33 is -33. Then we have, this is going to be -22i plus 330i minus 220. Now I can combine like terms. I've got this and this. Oops, no, this and this one are like terms, and the I terms are like terms. So adding the numbers together first, because we wanted this in standard form, it's going to be negative 253, and then minus 22 plus 330, that's going to give us plus 308i. And that's in standard a plus bi form. Now, for this one, I'm going to distribute the first into the second. 4 times 4 is 16. 4 times 9 is 36i. Negative 9i times times 4 is going to be negative 36i. And then finally we get negative 81i squared. Now, this is the important thing here. Plus 36i minus 36i, those cancel. I squared is negative 1, so negative 1 times negative 81 is positive 81. And we get 16 times 81, or 16 plus 81 is 97. Of course, this is 97 plus 0i, so that's standard complex form. But you can see here we multiplied two complex numbers and we got just a real number from it. Give it a try in number 2. All right, so this last problem here where you can see we have the complex portion cancels and we get just a real number. This is a special type of problem because it multiplies a complex number with its conjugate. And the complex conjugate of a number a plus bi is a minus bi, or vice versa. If you have a minus bi, the complex conjugate is a plus bi. All you do is you change the middle sign. Whatever it was, flip it, and then you have the complex conjugate. This has important geometric ideas into it, and so we can graph complex numbers using a two-dimensional plane because there's two real number choices, a and b. Both of those can be any real number, and that makes it a two-dimensional number. So we can graph it on the complex plane, where a is the real portion. It's going to be the horizontal axis down here. Coming right like this, the real axis. And then we have the imaginary axis here on the vertical one. And so we have a here, and then bi is the vertical one. So we can graph 1 plus 2i. 1 is the real portion. It's going to go on the x-axis, so 1 is going to be right here. And then 2i is the imaginary portion. That's going to be the height on the y-axis. 2i is here. So 1 plus 2i, I can show that by just graphing this point. That point is 1 plus 2i. Now the conjugate of 1 plus 2i is 1 minus 2i. So 1 is still here in the real number line, and minus 2i is right here. So 1 minus 2i is this number here. Okay, let's multiply these two conjugate pairs together. Okay, we're going to distribute the 1. We're going to get 1 minus 2i. Then distribute the 2i. So we're going to get plus 2i minus 4i squared. You can notice that the 2i's cancel. Minus 4i squared. I squared is negative 1. Negative 1 times negative 4 is plus 4. So we get 5. And I can graph this actually on the real plane again. 5 is right here. It's 5 plus 0i, right? It's the same thing as 5 plus 0i. So these two numbers multiplied together graph to give you this number here. Now let's look at another couple. Graph negative 1/2i and its conjugate. Negative 1/2i is going to be right here. That's negative 1/2i. And then it's got no real part, so we don't go left or right at all. This is the same thing as 0 minus 1/2i. So this is going to be left or right, none, but just down 1/2 a unit, and that's negative 1/2i. Then we can graph the conjugate of this, which if it's 0 minus 1/2i, the conjugate is 0 plus 1/2i. All you do is you change that middle sign there. And that's going to be right here. Now to multiply them, of course I could multiply these two numbers, but There's no real reason to do that. Just multiply negative 1/2 I and 1/2 I. We're going to get negative 1/4 I squared. I squared is negative 1, so we have negative 1 times negative 1/4, which is positive 1/4. Positive 1/4 is right here. And you may notice this, but we had this portion right here. This is the first number we had, and the second number we had down here. And what this is actually is a mirror image right across the x-axis. It's the same thing with the second number. This was 1/2 I, and this was negative 1/2 I, and they're mirror images right across this x-axis. Just flip it over the x-axis, and you get the same point. And that's what conjugates always do. They always flip across the x-axis. So, for instance, the conjugate of negative 2 plus 3i is going to be negative 2 minus 3i. Those are conjugate pairs. And when you multiply conjugate pairs, you always get a real number because the conjugate or the imaginary portion always gets I squared, and then it gets negative 1, so it goes away. Or in the case of numbers with multiple parts, they cancel. So the imaginary portion always cancels when you multiply conjugate numbers, and they flatten down to the real line. Now, we use conjugate pairs in division of complex numbers because the division is a little confusing since we have an I underneath of it, and an I is a square root, and that's kind of a little bit confusing, especially when it's a square root of a negative number. But we can simplify this thing down by multiplying by its conjugate. So here we have 5 minus 5i. I'm going to multiply top and bottom by the conjugate 5 plus 5i. Doing that, well, on the top we're going to get we're going to distribute the 18 and the 20i through. That's going to give us 90 plus 90i minus 100i minus 100i squared. On bottom we get 25 minus 25i plus, or no, sorry, this is plus 25i minus 25i minus 25i squared. Okay, now I can combine like terms on top and bottom. I have those cancel. I squared is negative 1, so I can remove this and change it to a plus. The same thing on bottom here. Negative 25 times negative 1 is just positive 25. Okay, on top I have 100 plus 90 is 190. 90i minus 100 is going to be negative 10i. On bottom I have 25 plus 25 is 50. I can simplify this down by 10 on everything. I can divide everything by 10. It's going to be 19 minus I over 5. And I can write this in standard complex form by breaking up the fraction. 19 over 5 minus 1 over 5i. And this is in standard complex form, a plus bi. This we can graph, we can work with. So division of a complex number is just the same thing as a complex number, just like when you divide two real numbers, you get a real number. If you divide two complex numbers, you get a regular complex number. And this is a lot easier to work with than this division. Give it a try in number 3.